Hello and welcome to part 3 of CA Service Management Containerization video series. In this video, I will explain and showcase how to deploy CA Service Catalog containers, customize and fine-tune your application in containers. I will also cover few migration considerations along with debugging and troubleshooting tips. It's recommended to have a basic understanding of container terminologies and concepts for a seamless deployment experience. I need to consider and plan for the following prerequisites before going ahead with the deployment procedures. First of all, I must have a Kubernetes cluster with one master node and at least one or two worker nodes. I need to ensure that both master and worker node of Docker. I also need to have a persistent volume that is mounted on the NFS server. I am going to use Ingress Nginx for load balancing. Using Kubernetes dashboard is optional and can be used along with kubectl commands. CA Service Catalog containers support both Microsoft SQL Server Database and Oracle databases. The database server, CAEEM and Process Automation or PAM servers will remain outside the Kubernetes cluster. In a solution environment, where administrators are going to deploy CA Service Desk Manager and CA Service Catalog, it's recommended to first deploy CA Service Desk Manager and then deploy CA Service Catalog. CA Service Management continues to support most of the supported catalog utilities in containers also. The utilities supported in containers include and targets, ixutil and safex commands, ldap and seed-dated importer, import and creation of content packs, telemetry support for catalog. There are few non-supported utilities for catalog containers. For ISO-based catalog deployment, administrators use the setup utility to configure CAEEM, process automation, and MDB. For container-based deployment, setup utility is not supported for catalog. For container deployment, we will be using the config maps. Config maps is the single source of truth for all user inputs to get the container up and running. As we move ahead with the deployment process, I will showcase how to update the config maps. Accounting service is not supported, so catalog accounting module is not going to be a part of containers. Auto integration of CA Service Catalog and CA Asset Portfolio Management is not supported. If there is a requirement to integrate both these products, then administrators are required to integrate it manually. Now, let's get started with the deployment. This is my master node and here I have deployed Catalog. This is the Chasm Docker installer for CA Service Catalog. I downloaded this from the Broadcom product download site. After unzipping and extracting, open the containers.config file. In the containers.config file, update all the required details like license agreement or EULA, SSL certificate name for an SSL environment, database types, database server details, CAAIM server details like CAAIM admin username, process automation URL details, and telemetry details. Similarly, I have updated the containers images file and generated secrets using the generate.secrets script. This will generate the encrypted secrets and will reside in the Kubernetes secrets file. After completing these configurations, I will go ahead and run apply.sh catalog script. This updates the configuration changes for CA Service Catalog in Kubernetes environment. Here, as you can see, I have deployed one pod. Note that when you run the apply.sh space script, it's recommended that you must cross-verify your changes in config maps on the Kubernetes dashboard to check whether the details are correct. The config map contains configuration details. For example, the MDB config contains the database details. Process automation or PAM config has the PAM URL and PAM username. AIM config map will have the AIM details. SLCM config will have the out-of-the-box offerings to be deployed. By default, the values are set to no. To deploy these offerings, navigate to the container's recommended config file and here you can update the application services. Default value is false. To update the values, make it as true. You can redeploy the application using the command apply.sh space catalog. Once I am sure that everything is appropriately configured, from the stateful sets in Kubernetes dashboard I will increase the replica count to 1. By default, the replica count is 0. Make it to 1 after successful deployment of catalog. I want to increase the replica count of this pod to 2. I have the option of doing it via the Kubernetes dashboard or via the kubectl command. For now, I will use the kubectl command to increase the pod replica. Provide the replica count as 2, and the namespace as chasm docker. On the Kubernetes dashboard, the pod status is currently in red. Once the pod is up and running, this changed to green. It takes some minutes for a pod to be up and running. While the pod is coming up, let's discuss persistent volumes. These are the out-of-the-box persistent volumes for CA Service Catalog. Catalog has 3 kinds of persistent volumes. Catalog config PVC with chasm docker as the namespace. Catalog conf PVC and some random number. These has all configuration-related files like log4j.xml. This is generally used to increase the log level. cache XML to cache the form data request information. Server.xml, web.xml, viewservice.config, config.properties. All these configurations are mounted in the catalog.conference PVC. Similarly, there's the chasm docker catalog file store PVC which holds all customization-related folders covered in the upcoming slides. Another important persistent volume is the dynamic PV. The first 2 PVs, config PV and file store PV, are common for all the pods. Let me refresh the page. You can see 2 dynamic PVs. One is catalog 0 and the other one is catalog 1. As you can see on the Kubernetes dashboard, both the pods are up and running. These 2 persistent volumes belong to each pod and contain logs and JMS data for pods. They are specific to these 2 pods. Whereas the catalog conf and catalog file store PVCs are common for all the pods. Now, you can see that both the pods are up and running. This is the external URL or the ingress URL. I will now log in to CA Service Catalog. See that catalog is up and running with 2 pods. Similarly, we can reduce the replica count to 1 or 0 by using the same kubectl command or from the Kubernetes dashboard. Now, coming to troubleshooting and debugging tips. I will cover 2 most common scenarios where deployment failures are seen. Deployment failures mostly occur when incorrect configuration details are provided in the containers config file for process automation or PAM, MDB, CAEM. Verify the status of the pod on the Kubernetes dashboard. Pods show up in red to indicate that deployment was not successful. To debug this issue, log in to the said pod by executing this command. Also navigate to the tmp/chasm folder. This folder contains deployment logs and information. Open the chasm install report to see whether deployment was successful or not. If you see the installation status is completed, which means that installation happened successfully. You can also check the MDB folder. Navigate to /tmp/chasm/mdb to verify the install.log file. Check the chasm install report and observe that few components are failed during integration with CA common components like PAM or process automation or AIM. For example, if I provide an incorrect host name or incorrect password, or incorrect AIM, PAM, MDB details, the deployment will fail. To find the root cause of the failure, navigate to tmp chasm mdb folder and open the install.log, which contains installation failure errors like incorrect AIM server details. Open the containers.config file, and go to the AIM details section and correct the server details for AIM. Rerun the apply.sh space catalog. Stateful set on the Kubernetes dashboard will become 0 again. Increase the replica count. Now the pod will deploy successfully. Next debugging scenario is where you encounter catalog application issues even if CA service catalog deployment happens successfully. For example, debugging the request flow. Usually, to resolve such issues, I will enable the log level to trace and then verify the logs. Select the Chasm Docker Catalog Configuration PVC and open the log4j.xml file. Then, search for view.log. If it is info, make it to trace. From the persistent volumes, navigate to Dynamic PVCs, to check Catalog 1 and Catalog 0. Then check the logs to know the root cause of the issue. Coming to migration considerations, if you are upgrading from an earlier version. CA Service Catalog containers support migration or upgrade from CA Service Management 14.1 and later versions, and 17.1 and later versions. Before kickstarting the migration process, take a backup of the MDB database. For file store customizations in containers, follow the same migration considerations and methods that you perform for an ISO-based deployment. In containers, file store is mounted on the NFS share persistent volumes. After upgrading to CA Service Management 17.3, redo the customizations for catalog file store and compare the changes. For more information, see CA Service Management documentation. Catalog is a highly customizable application and all customizations that are supported for an ISO-based deployment are supported for catalog containers. To customize, navigate to persistent volume location and make required changes like changing images, application logo, themes, add or update the CSS file. Note that few customizations require pod restart and while few others do not. For example, XML changes do not require a pod restart whereas changes to Java plugins require a pod restart. To fine-tune catalog containers and improve performance, go to containers_recommended.config file. This file contains pod resources like pod memory, pod CPUs and modify these parameters to improve catalog performance. Similarly, modify the server.xml file. Server.xml is mounted in the Chasm Docker Catalog config file. Edit this file and change the max threads value. Default value is 400. To fine-tune performance, update the acache XML file located in catalog conf PVC. Out-of-the-box value is 2 seconds. To improve performance, increase the value. This file is common for all pods in CA Service Management containers. After making the changes to these files, restart the pods. So this is how you can fine-tune catalog containers.